So this is the second video for lesson 18. In video 1 we went ahead and talked about tables, and then now I'm going to talk about graphs. So I'm going to go here, and here's my graph paper. I'm going to use the same values that we talked about in the first video. So let me go ahead and copy those tables over. So here I had my Fahrenheit degrees, and I'm converting it to Celsius. And I said 32 degrees in Fahrenheit is equal to 0 degrees Celsius, 50 degrees is equal to 10 degrees, 70 degrees is equal to 21.1 degrees. And then the chart that my friend Camille would have made is she would take Celsius and then convert it to Fahrenheit. So 10 degrees is equal to 50 degrees, 21.1 degrees is equal to 70 degrees, and she would find this chart here. Really useful, so that she can communicate with me. Okay, so in video 1 we talked about how these x and y values were switched for these inverse functions. So let's go ahead and label this as x and y, where x is the input, f is the output. X is the input, f is the output. And I'm going to go ahead and graph these points now. Okay, so let me make my graph, give myself a little bit of room. Let me go ahead and also grab another color so you can see this a little bit better. Here's my purple, here's my pink. And I'm going to go ahead and plot lines out in pink. So here is Miss Twants going from Fahrenheit to Celsius. And I have the point 32, 0. So this is x, this is y. And 32, 0 would be here. If I just go ahead and label this as 10, 20, and 30. So 32, 0 will be approximately here. Here's my first point. And then my second point would be at 50, 10. So 1, 2, 3, 4, 5, and 10 degrees up. And then now 70 degrees matches to 21.1. And let me go ahead and graph that. 1, 2, 3, 4, 5, 6, 7, and 21. Okay. Notice how I'm just labeling these as x and y's. So this is just input, and this is output. Okay, once I've graphed those 3 points, I know that there can be many other temperatures in between, so I can go ahead and just draw a straight line through these points. Okay, now let me go take a look at my second function, or my second table here. If I take these points, I'm going to go ahead and label them. At 0, I have 32 degrees, so 0, 1, 2, 3, 32. Here's my first point. Second point, at 10 degrees Celsius, I have 50 degrees, so 10, 1, 2, 3, 4, 5. And at 21, I have 70, so going over to 21, 1, 2, 3, 4, 5, 6, 7, 70. Okay, so once I've gone ahead and done that, I'm going to also draw sort of a straight line through these points. Okay, what you will notice is now that you have, excuse that, Belle. But anyways, here we have 2 graphs. And what I want you guys to start to notice is with inverse functions, there's a very interesting symmetrical pattern here. See if you can pause the video and just figure it out. And once you think you figure it out, I'm going to ask you, what is the line of symmetry? And when I take a look at the line of symmetries, it looks like each of these points, they match up. And the way they actually match up is if I go ahead and draw a line in at y is equal to x, if I go ahead and fold this paper over, you'll notice that this point reflects over this line at this point, this point reflects over this line at this point, this point reflects over this line at this point. So this is a very key property where y is equal to x is the line of symmetry between these 2 inverse functions. So that means if I were to be given a random looking graph, say for example something like this, the inverse function we would know just by looking at this graph is a graph that is a reflection across that line. So this would be the function, this would be the inverse function, just by looking at the graph. And that is a key point about graphs for inverse functions. So check.